Want to see an out-of-this-world true detective story? Well, sharpen your wits and hop on your magic carpet. You've got one, you know. Your imagination. Phantom invaders from outer space. Master keys to nuclear magic. Adventure, discovery, the greatest 50 years in the history of mankind. But how do we package all that into a show?
It's very simple. We ask your magic screen.
I have. But when it's blank up here, it's blank up...
The magic screen.
Boing. Maybe it isn't so blank up here. Come on, magic screen, come up with something.
Here we are back in Mysteryland, ladies and gentlemen, and man, oh man, have we got excitement. Great night, great night. Everybody's got a detective story candidate. Agatha Christie, Earl Stanley Gardner, Dorothy Sayers. Everybody's got a candidate as the crowd mills around the famous Academy of Detection Arts and Sciences. And no wonder. Being voted on tonight is the award. The Edgar, it's called, for the best detective story of the first half of the 20th century.
Best detective story.
Ed, any word from the judges yet? Take it away, Ed.
You can just barely see the judges. Boy, are they sweating. There they are.
This is an absolute bore. These writers?
Mystery schmistery. On the first page, I know who did it. who done it.
You all recognize the chairman, Edgar Allan Poe, whose Murders in the Rue Morgue won the first Edgar.
Nevermore, nevermore.
To his right, Charles Dickens, who gave us one of the strangest detective stories ever penned, The Unfinished Mystery of Edwin Drood. And on the chairman's left is Fyodor Mikhailovich Dostoevsky. And that golden skull you see on the table, that's the winner's prize, the coveted Edgar.
Of course. That's it. That's us. Gentlemen.
What are you doing?
Most honorable judges, we have an entry for you.
Another entry.
What's he talking about?
The contest is closed.
Well, how can it be when we've got the greatest detective story of the last 50 years? The Strange Case of the Cosmic Rays.
Cosmic Ray.
Strange Case of the Cosmic Rays. An excellent title.
You realize, of course, the detective story has certain requirements.
Analysis, deduction, seemingly insignificant clues.
That's right.
Well, our story begins with a clue so insignificant, Mr. Poe, it wasn't even noticed for 100 years or more.
The detective story is literature. It must have scope.
Scope, he says. Jim, roll 3. Why, the Cosmic Ray case has helped to revolutionize the modern world. Look, have a look. Atomic power plants for the future. Atomic subs. Atomic planes. Radioactive drugstores. Isotopes for medicine. And hold on to your hats. How's that for scope? Well, gentlemen, do we qualify?
Theodore?
Нет. Science is for me a big bore.
A big bore? Why, do you realize that just while you were speaking, the criminal in our case fired 20 atomic bullets through your head?
Good. Holes in the head I like.
And you traced this criminal through that tiny clue you spoke of?
Yes.
The story begins as an ordinary theft. Theft from this simple electroscope, a common instrument that's been in use to detect radiation for generations. It's just an airtight jar with an insulated metal rod, from one end of which hang 2 pieces of gold leaf. Now, normally, they hang straight down. Thank you, boy. But as every school kid knows, when an electric charge is put on the rod, so the leaves become charged. Now, as to the detection powers of the electroscope. When radiation is from this piece of uranium, for instance, enters the jar, the air inside is broken up into charged fragments, some of which neutralize the charge on the leaves and cause them to fall. And the stronger the radiation, the faster they fall.
What is this, a schoolroom? Where is the mystery?
Well, the mystery is that when a charged electroscope was put aside, when no known radiation was around, the gold leaves mysteriously lost their charge and collapsed anyway.
The tiny clue.
So, is leaking a little electricity. That's a bank robbery?
That's just how science thought of it. Bank robbery. Roll 4. Now, imagine the charged electroscope as a kind of bank, and the known radiations as thieves, bank robbers. Yeah, there you are. Depositors putting their hard-earned electrons into savings accounts. Wait a minute. That's no depositor there. That's Miss Ultraviolet Ray. She's one of the slyest of our robbers. Lift the electrons right off your back.
Drop up and have a jolt sometime.
Don't you do it. There's a distant cousin of Violet's over there, Gamma Ray. Ordinary walls don't mean a thing to him. Wow, here comes a real tough bunch in from the hideout. The Uranium Gang. Those hombres have been in and out of the calaboose so often they go by numbers. 234, 235, and 238. I hope 235's not carrying what I think he is. You know, those boys are the atom bomb boys.
Help! Help! Sheriff! Robbery! Help! They went that away!
Put on more guards! This thievery has got to stop! Rebuild the bank! Put lead walls around it, 9 feet thick!
So with 9 feet around it, the electroscope bank became the Fort Knox of science. Not one of our robbers was sly enough like Ultraviolet.
Thank you.
Or persistent enough like Old Gamma.
Thank you.
Or powerful enough like the Numbers boys to break in.
No more breaking into my bank.
Help!
Hey, wait a minute. What's wrong now?
Mr. President, another robbery!
Brother, somebody has broken in.
Must be a phantom bandit. A phantom bandit? Get the town marshal, get the army, the navy, call out the Marines. He must be caught.
That is literature?
Well, it's...
The point we're trying to make, gentlemen, is that just a few inches of lead would shield any electroscope from all known radiations, even from the most powerful X-rays. But this new radiation, why, even lead walls 9 feet thick couldn't keep it from crashing through and collapsing the leaves. That meant that some unknown, super powerful, ghostly radiation was loose in the world.
Where did this phantom come from?
The first guess was that it came from some new radioactive element in the Earth. But how to prove this? A Jesuit physicist, Theodor Wolff, thought he had a way. Father Wolff reasoned, if the phantom radiation came from the Earth, the higher you got in the air, the weaker it would be, and the slower it would discharge the leaves of an electroscope. In 1910, the good father went to the foot of the Eiffel Tower. He charged his electroscope and then carefully measured how long it took the unknown radiation to steal the charge from the leaves. First picture of the tracks of a hitherto unknown particle of matter, a positive electron.
A particle. Positively charged. Why couldn't that be Fagin, Dosty, instead of your proton?
I move we reject the entry.
Second the motion.
Third.
Why, Mr. Poe?
By introducing a new suspect at this late date, you have violated a cardinal rule of the detective story.
Yeah, it's cheating. It's my money.
But think of the impact of this discovery, Edgar. Why, it's as if your Detective Dupin, searching for a human criminal, ran across an unknown species of man. It's astounding.
It's cheating.
A brand new kind of matter has been discovered.
Yes.
And a fourth henchman for Fagin. The positron.
Bah! What difference? Positron, proton, pimpleton. This is useful. Is big doings about little nothings.
Now, wait a minute, Dusty. Out of little nothings like this have come the big doings of science. Newton wondering why an apple hits his head. Out of that came the law of gravitation. Röntgen, in trying to figure out why his photographic plates got fogged, came up with X-rays. Maxwell, tinkering with some tricky equations, came up with the key to television.
And this chase after little particles is the key for something big?
Just about the biggest something man ever ran into, Mr. Dostoevsky. Nuclear force.
Nuclear force?
That's big.
Nuclear force. We've heard rumors about that.
Exactly what is meant by force?
That's a large order, Mr. Poe. If I could answer that, I'd be 10 Einsteins rolled in one. But in general, by force, science means a strange, almost mystic quality or power possessed by matter. It manifests itself in three ways: gravitational force, electromagnetic force, and nuclear force.
Oh, yes, you see the three, yes.
Now, in a sense, a force can be likened to an army. Force exerts its power through individual units, just as an army does through its individual units or soldiers. With gravity, the force that holds the whirling planets in their orbits, the smallest individual unit, the soldier that does this planet holding, is said by some scientists to be the graviton, although this graviton has never been pinned down or observed in any way. Now, if we focus down to just one atom, not large bodies, but just one atom, helium, for instance, another force takes over. Electromagnetic force. Now, this second force keeps the atomic solar system from flying apart.
And the electromagnetic soldier?
That's called the photon. And unlike the graviton, this photon has been measured and directly observed. Now, if we go deep into the heart of the atom, into its nucleus, we come to the third and most sensational force. Nuclear force. That's the force that holds the protons and neutrons locked in the tiny nucleus. The awesome force man is now unlocking for his own use. The force which will surely change the way of life for every man, woman, and child on Earth.
And the soldier?
The soldier that does the holding in nuclear force? That, dramatically enough, came out of the cosmic ray chase, out of tracking down Fagin's henchmen.
Here's the way it happened. And boy, this really rocked the science world. In Japan in 1935, at Osaka University, a genius named Hideki Yukawa sat alone with a pencil and a piece of paper, and he came up with a most amazing prediction. He said that the soldier, the unit of this terrific new force, would appear, believe it or not, as a small particle, a piece of actual matter. He calculated it'd be about 200 times heavier than the electron, and get this, would live about 1/millionth of a second, then poof, it would disappear, die. Well, this was just too deep even for the highbrows. Yukawa's prediction dropped like a feather in the scientific pond. But meanwhile, the cosmic ray chase was still going on. Since the discovery of the positron, the scientific working stiffs were photographing cloud chamber tracks around the clock to see if there were more new particles among Fagin's henchmen. Well, up popped the devil. Seth Nedemeyer and Carl Anderson of Caltech and J.C. Street, Denise E. Stevenson of Harvard, all came up with a new track at about the same time.
What is it?
A real oddball. The track of a particle more than 200 times heavier than an electron, and which, if you please, lives only a millionth of a second or so.
Yukawa's prediction. His nuclear soldier.
Why, of course.
No, doggone it.
Oh?
This strange new particle, called a mu meson, just didn't behave as Yukawa said it should. It wasn't quite the nuclear soldier he'd predicted.
There was a bit of disappointment on Yukawa's prophetic face. But there was no disappointment in the particle department. The bug-eyed cosmic ray detectives realized that they'd stumbled onto another brand new piece of matter that no one ever dreamed existed. And another henchman for Fagin's rogues gallery, the mu meson.
And then some 10 years later came the happy ending. Happy for the Japanese wizard. It came from the developing tanks of a laboratory in the University of Bristol, England. On photographic plates exposed on the tops of the Bolivian Andes and the French Pyrenees, 3 astonished cosmic ray hunters, an Englishman, C.F. Powell, an Italian, G.P.S. Occhialini, and a Brazilian, C.M. Lattice, ran across the track of a quite similar but heavier meson.
Eureka! This was it. This soldier did obey orders.
This newer particle, it's called a pi meson, did seem to fit Yukawa's equations. His amazing prediction came true, and he was awarded a Nobel Prize for it. Now, Mr. Poe, I think I can answer your question. Most people believe that the unit of nuclear force, the tremendously powerful soldier that holds the heart of the atom together, is the pi meson.
Pi meson,
Yes.
And a 6th Fagin henchman got his name on the police blotter. The pi meson.
But weren't the detectives a bit confused by all these odd henchmen of Fagin's?
Yes, I should think they would be, yes.
Confused. They were bewitched, bothered, and bewildered.
Yes, and they still are. Think of it. As late as 1932, science had the universe all neatly wrapped up in 3 little basic packages: electron, proton, neutron. Just 25 years later, in 1957, the number of separate and distinct particles of matter had jumped to at least 20.
Including 2 really out-of-this-world babies. The neutrino, a kind of ghost particle that leaves no footprints, yet apparently zips through lead as if it were butter. And the newly discovered antiproton, which some people think is one of the building blocks of an unseen world, a sort of left-handed world of matter matching the right-handed world we live in.
Yes, not to mention K mesons, tau mesons, hyperons, V particles.
A veritable deluge.
And no one knows how many more henchmen are going to show up or what they're going to mean. Scientists are crying for a Moses to lead them out of the wilderness of nuclear particles.
I says proton.
Yes, yes. Well, what about the detective story? What about Fagin?
Oh, yes, yes.
Oh, they nailed Fagin, all right. To do it, they went right up through the air ocean and took his picture.
His picture?
Well, perhaps impression is a better word.
Okay, Doc. Impression. With this new detection gadget, it's a cosmic ray emulsion plate. It's very much like an ordinary photographic plate, only it's more sensitive, and it's got a much thicker coating of silver bromide. Now, the aim of the science detectives was to get a flash of old Fagin on here before he smashed into our air atoms. Well, obviously, that meant going very high indeed, way up almost to the top of our atmosphere, where the population of air atoms is very scarce. With these lightweight plates and a new kind of balloon named the skyhook, they did the trick.
Skyhooks quite easily carry instruments up to 140,000 feet or more and can stay up there for several days.
During which time police switchboards buzz with flying saucer reports.
Ah, but it's with rockets that we really take instruments up into Fagin's home territory. Up to 150 miles, up to where the emulsion plate is face-to-face with Fagin himself. From dozens of rocket flights from literally hundreds of balloon launchings all over the world. picture of the master criminal began to emerge after a king-size chase of over 50 years. Here's what Fagin looks like, or rather what his trail looks like, as he smashes through the silver bromide on the photographic plate.
And this is what happens when Fagin hits one of the silver atoms square on the nucleus. Weight for weight, he's got the biggest sock in the universe. The first to actually mug Fagin were some Chicago detectives.
Yes, a group of physicists headed by Marcel Shine. From microscopic examinations of the tracks left in their emulsions, they announced that most of the Fagins, the primary rays from outer space, were protons, naked hydrogen atoms stripped of their electrons.
Protons! I was right. Give me the money.
No, Fedor,
Yes,
not so
Charles,
fast.
I win the money.
You have one nothing.
Yes.
Order,
Yes,
gentlemen.
sir. I'll ask him. Doctor, search me. I was right. No?
Only partially right, Mr. Dostoevsky. In 1948, physicists from the universities of Minnesota and Rochester found other primary tracks, too heavy, too highly charged to be protons. And the most numerous of these were made by naked helium atoms. And in addition, the tracks of still heavier atoms were found. In other words, the Fagins are really atoms, common familiar atoms, stripped of their electrons and hurtling through space at unholy speeds. Atomic bullets from beyond the beyond, crashing into us with almost the speed of light.
And when he says crash, he means crash. These cosmic ray babies crack into us with energies of more than 1,000,000 billion electron volts. More than 5 million times as strong as an A-bomb atom. That's our space boy, Fagin. And his identity? Naked atom.
Amazing. Absolutely amazing.
My money.
But no more amazing than the detectives who tracked him down.
Do you mean to say they actually know where he comes from?
Well, they've got one pretty good idea. Tell them about it, Doc.
Well, many scientists now think the cosmic Fagins are being spawned continuously in our own galaxy, the Milky Way. They believe that all stars, including our own sun, are constantly casting off particles into space through surface explosions, and that these cast-off star particles, zillions and zillions of them, gradually acquire their cosmic speeds and energies by being bounced back and forth between galactic clouds.
Galactic clouds?
Yes, our own Milky Way, which looks something like our neighboring galaxy, Andromeda, contains not only billions of stars that spiral around, but also millions of truly enormous galactic clouds composed of dust and gas. These galactic clouds float and swirl through the Milky Way in all directions. Sometimes they look black and they obscure the stars behind them. These swirling clouds apparently create gigantic magnetic fields. The late Enrico Fermi, one of the great pioneers of modern science, Fermi suggested that within our Milky Way, gargantuan badminton games go on, in which the players are these huge magnetic fields, and the birds are tiny naked atoms which have been shot into space from erupting stars. And the atoms are naked because the star heat is so intense that atoms can't hang on to their satellite electrons as they do at normal temperatures.
What does it mean?
When such an atom is exploded into space from a star, it will eventually collide with a magnetic field and bounce off. It will bounce off with more speed if the field is moving toward it. Years later, it runs into another gigantic field and is sent shooting off in another direction. After 1,000,000 years or so of this being batted back and forth, these atoms, they're our Fagins, and remember their number is countless, are kicked up to almost the speed of light and sent hurtling through our Milky Way in all directions. And the tiny dot, which is our Earth, moving through space, sails through this myriad of shooting particles, and a tiny fraction of them crash into us as cosmic rays.
Gentlemen, do you realize what this means? The Fagins bombarding us from outer space are pieces of matter from billions of stars. And since these space bullets are the same atomic particles we have on Earth, That means the stars are made of the same stuff we're made of. A part of the eggs you had for breakfast this morning could have come from Orion. Or from the Big Dipper. And some of the carbon in this young lady's shining red hair might once upon a time have been stardust from an exploded supernova. Or from the Southern Cross. Why, you could almost say that in tracking down Fagin, the science detectives uncovered material proof of the oneness of the whole great cosmos.
Mr. Scientist, for highbrows, this could be exciting. Maybe. But what is meaningful for common people who work, love, hate?
Yes. What is the meaning for ordinary mortals?
Oh, a very big meaning indeed, Mr. Dostoevsky. It's possible that how people work, love, hate, has been, and is even now being affected by cosmic rays. It's possible that in the millions and billions of years they've been bombarding the Earth, these cosmic space bullets could be partly responsible for evolution by causing mutations, sudden changes, as they smash into our reproductive genes.
My word.
Why, Dusty, it's conceivable that your enormous writing talent could be traced to some well-directed cosmic ray hitting your great-grandfather in just the right gene.
My writing? Cosmic rays?
Do you realize what this would mean philosophically, Edgar? That changes in living things may be controlled by the stars.
And still more significant, Mr. Dickens.
Yes?
Someday, out of the strange case of the cosmic rays, out of this out-of-the-world detective story, may come the answer to the great riddle of what makes the universe tick.
Well, gentlemen, how about it? Do we get the Edgar?
Charles.
Yes.
I make my vote now.
Yeah, I know. Yet.
No, not yet. Science is for people. I thought it was just for long hairs. I vote yes.
You do?
Yes. A truly remarkable story.
Hey, Doc, did you hear that?
But an epic adventure of the human spirit, the mind of man, daring to explore the unknown reaches of the heavens just to track down these tiny particles of stardust, so packed with primeval power, they come winging with the speed of light. Celestial messengers from out where the morning stars sing together.
Good line, Charles. Excellent poetry.
You like it, Fedor?
But what is the message they bring? And why?
Huh?
What?
Gentlemen, we thank you for a saga of brilliant scientific accomplishment. But as a detective story, and that's what we're judging, as a detective story, your tale has a fundamental weakness. Motive.
Motive.
Fedor, they've established no motive for their cosmic Fagins.
But Edgar.
Why do they bombard the Earth?
Edgar, if they knew motive for cosmic rays, they'd have answer to great mystery of creation itself. I vote yes.
I vote no. Their story's unfinished.
Charles, you vote yes. No?
You know, I'm reminded of Isaac Newton.
He's reminded. It's a good story. Give him
Just
the
a moment, Fedor. Just a moment, Fedor. I haven't finished. I'm reminded of Isaac Newton, perhaps the greatest scientific mind that ever lived, and how he humbly described his monumental discoveries as now and then finding a smoother pebble or a prettier shell, while the great ocean of truth lay before me.
Pebbles,
Well, that great ocean of truth still lies undiscovered before you.
Briefly, Charles, how do you vote?
I vote we invite these gentlemen to come back in 50 years to tell us what new chapters they've added to their cosmic tale.
Ah, excellent, Charles.
Thank you.
Most excellent.
And who will write these new chapters? The young. The inheritors of all the knowledge and culture of the ages. Of all the dreams and hopes of those who went before us. What an exciting time to be young.
Yes, and what a glorious opportunity to add to man's history, to harness these nuclear fires for man's use, to accept the challenge of creation, and to use the gifts God gave us to explore the grandest of all frontiers, the universe. For the more we know of creation, the closer we get to the Creator.
3 cheers for Stardust.
Bell Telephone System takes pride in bringing you this program in its series of shows on science. We wish to express our gratitude to the distinguished Board of Advisors who guide the choice and treatment of scientific matter for the series. Biology and genetics, medicine, bacteriology and botany, chemistry, geophysics, physics, anthropology, mathematics, engineering. For the program you have just seen, our thanks to the special advisors who have suggested and checked the scientific material. The Bell Telephone System is indebted to all these men and to many institutions for the generous support they have given this venture in public education through entertainment.
Powerful cosmic rays smash through spaceships. But how can objects smaller than an atom carry enough energy to be dangerous to astronauts?
Moving objects carry energy. We call this kinetic energy. And when they strike something, they transform that energy. When I hit my hand, the kinetic energy of my fist transforms into sound and heat and vibration. My hand hurts a little from that impact, from the transformation of energy.
It's the same thing with cosmic rays. When they slam into a human brain cell or a computer chip, they dump some energy, causing damage. How much damage depends on their kinetic energy, and that comes down to two things: mass and speed.
Intuitively, things that are moving at the same speed, if they're more massive, they carry more energy. A bigger asteroid slamming into Earth will do more damage than a smaller asteroid.
If you double the mass of an object, its kinetic energy also doubles. Although mass is important, it's not as important as speed.
Speed matters even more than mass. The kinetic energy depends directly on the mass, but it depends on the square of the speed. Here's what that means. You double the mass, you have double the kinetic energy. You double the speed, you have 4 times the kinetic energy.
When it comes to speed, cosmic rays are the elite. An ultra-high energy cosmic ray, detected in 1991, hit the atmosphere so fast, scientists called it the "oh my God" particle.
This particle was higher energy than they thought they would ever see.
Until this fluorescent streak in the Utah sky, no one believed the particle could reach the Earth, traveling so close to the speed of light, making cosmic ray particles far more dangerous than expected.
As you approach the speed of light, energy, momentum, mass, they start to act a little bit differently.
Einstein's equations of relativity become important. The physics changes, and the energy it has becomes much stronger.
If a particle is moving at close to the speed of light, that means that its energy is almost at the maximum allowed by the laws of physics.
It's amazing to think that something as tiny as a proton could actually be dangerous to a human being. But amazingly, that proton is moving so fast, it carries as much energy as a baseball thrown at 100 miles an hour.
A baseball contains over 1 trillion protons. Imagine all that energy carried by just one particle.
So now you get a sense of just how risky these can be.
Ultra-high energy cosmic rays, like the "oh my God" particle, are like supersonic missiles. They are the fastest, but they're so rare, astronauts are unlikely to be hit by one. Solar cosmic rays are like BB pellets. Abundant, but our spacecraft can block them. The biggest threat to our astronauts, however, are galactic cosmic rays. They come from elsewhere in the Milky Way. The combination of their speed and frequency makes them the most dangerous.
These galactic cosmic rays are much more powerful than the solar cosmic rays. and they've traveled enormous distances to mess you up.